we start, let's remember one simple thing, which is that concrete is strong when it's being pushed, but weak when it's being pulled. In other words, it's strong in compression, but weak in tension. That's the main reason why pre-stressing is so important. So, what is the concept and principle of pre-stressing used in pre-stressed concrete? Basically, the concept of pre-stressing is a technique where we apply a compressive force to the concrete before any load is placed on it. High-strength steel wires or tendons are used for this. We stress the tendon tightly, and once the concrete hardens, we slowly release the tension. When that happens, the force from the steel gets transferred into the concrete, putting it into compression. This means the concrete is already squeezed or compressed even before it starts carry any real load. As a result, the concrete does not crack easily and can handle both compression and tension more effectively. The main principle behind pre-stressing is about balancing the stress. We purposely apply compression in areas where the tension is expected to happen when the structure is loaded. So, when the external load comes, the two forces, which is tension and compression, will balance each other. This keeps the concrete mostly in compression, which is its strongest state. That's why pre-stressed concrete can span longer, carry heavier loads, and stay durable over time.
Even though reinforced concrete is good at resisting both tensile and compressive forces, it still has some problems such as deflection. Deflection can open up the possibility for a lot of problems such as corrosion and cracks. But how can exactly we reduce deflection? The most common solution is pre-stress. There are two ways in which we can pre-stress the concrete. The first one is known as pre-tension and the second one is known as post-tension. Both of these methods require applying tension to the rebar and then releasing it, which then will transfer the loads into the concrete. Therefore, the tension will be reduced. In pre-tensioning, we apply the load to the rebar before the concrete has been cured, and then we release the tension after the concrete has been cured. In post-tensioning, we apply the tension and release the bar after the curing of the concrete. Pre-tensioning would require heavy equipment and good quality control, which means that it's usually pre-costed and then transported to the site. However, post-tensioning can be done on site.
Next, why pre-stressed concrete is preferred compared to conventional in-situ construction method? First, it enhances durability and crack control. In conventional reinforced concrete, cracks appear once tensile stress exceeds the tensile strength of concrete, allowing moisture and chloride to reach reinforcement bar and cause corrosion. Pre-stressed concrete greatly reducing crack formation. The Precast and Pre-stressed Concrete Institute notes that this leads to higher resistance to corrosion, carbonation and chemical attack. Therefore, a longer service life with lower maintenance costs. Second, structural performance. According to Nielsen, in design of concrete structure, pre-stressed members capable of spanning much longer distance than conventional reinforced concrete. For example, while conventional beam typically span 6 to 12 meters, pre-stressed concrete can efficiently span 20 to 40 meters without intermediate support. Third, it improves quality control. Pre-stressed concrete elements are usually manufactured in a precast factory under controlled temperature, humidity, and curing conditions. This contrasts with conventional in-situ concrete, which depend on site weather, worker skill, and curing conditions that are often inconsistent. The control environment ensures uniform strength, surface finish, and dimensional accuracy, reducing variability between elements. Fourth, its construction speed. Pre-stressed concrete allows faster project completion because it Components are produced off-site while site workers continue, are not affected by weather, require less curing time and involve quicker installation. As a result, total project duration can be shortened by 30 to 50% compared to conventional in situ method. Next, lower maintenance and longer service life. Due to fewer crack and higher quality, prestressed concrete structure require less maintenance and have a longer service periods. Over time, this results in lower total life cycle cost compared to conventional concrete. Last but not least, better site safety. The need for less formwork, scaffolding and on-site concrete pouring reduce risk to workers. Safer and cleaner site lead to fewer accident and better project management.
Next, how prestressed concrete contributes to SDG 9, Industry, Innovation and Infrastructure. First, build more resilient infrastructure. Second, support sustainable industrialization. And third, encourage innovation in construction. For SDG 11, Sustainable Cities and Communities, it will reduce urban disruption and faster delivery. It also increases space efficiency and flexibility and improve durability and disaster resilience. That's all from us. Thank you.